Okay, right. So this is the inverse that we calculated from the previous video, and we are going to find the domain of this inverse. Domain of f inverse of x. Like we said, to find the domain, if it's a fraction, we focus on the denominator. The denominator should never be a zero, which means that this is all real numbers except when 1 minus x equals 0. Because if 1 minus x, if the denominator is a 0, this function is undefined. So the domain is all real values except the denominator being a 0. So 1 minus x equals 0 implies x equals 1. So this is the value that we should exclude. Therefore, the domain of f inverse of x is all real numbers minus 1, or it's minus infinity up to 1 plus 1 up to infinity. And you use ordinary or normal brackets, no square brackets, because none of these values are included in the domain. Therefore, the range of f of x, not of the inverse of f of x, is all real numbers except 1, or it is minus infinity 1 plus 1 up to infinity. We find the inverse so that we can find the domain of that inverse. Once we have the domain of that inverse, we have the range of the function. So that is how you find the domain and range using the inverse method. So to find the domain, it's easy. You just look at the function. Does it have a square root? If it has a square root, you make sure that what is under the square root should not be negative. If it's a fraction, you look at the fraction, what is in the denominator should not be a 0. That is how you get the domain. But with the range, it's a bit tricky. You have to substitute each value. And that method, you cannot go anywhere with that method. It will take ages for you to get the range. So that is why we're using the method of inverse, where you find the inverse of that function. Once you found the inverse of that function, you find the domain, because it's easy to get the domain than the inverse, than the range. Once you have the domain of the inverse, that domain of the inverse is the same as the range of the original function. So that is how you get to that. Now, we are going to now find proof. Let me pause here, and then we'll continue in the next video, where we are going to prove that the inverse of a product matrix is the same as the product of the inverses of separate matrices. And also, we're going to prove that the transpose of a combined matrix or product matrix is the same as the product of the transpose of matrices. So let me stop this far. We meet in the next video, where I'll be working out a problem to clarify that. Thank you.